Hello and a good day albeit to the jurors and to the judges. So I am Daniel and I'll be presenting the compression ratio gauge on behalf of my team. So the introduction is that compression ratio of an engine is the ability of the engine to compress air-fuel mixture, and in this context the engine will be internal combustion engine, and it is vital to ensure a proper compression ratio is achieved for good performance and good fuel efficiency for the engine itself. An engine with a very low compression ratio will lead to poor performance and very bad fuel efficiency because the engine will need more fuel to perform at the optimum level. While on the other side, the engine with a really high compression ratio will lead to detonation or knocking, and at the end is going to create very severe damage to the engine itself. And the product usage for this prototype is only for internal combustion engine of motorized vehicles. So for the problem statement is that the traditional method, which involved manual control of the liquid flow from the burette into the cylinder head into the combustion chamber, which compromised the accuracy of water flow stoppage at the exact moment. Second one is the manual calculation, which also consists of extensive formula based on the availability of engine parts data. And with all these data and numbers, it will be really hard for the mechanics to write and to record everything because there will be 7 to 8 different data and all of them are numbers. They have to jot everything down, put it into the calculator, count it on, and then write it down again. So there will be a lot of room for mistakes to happen. And at this moment, high risk of parallax error and miscalculation can happen due to human control, as some mechanics might have sinus problem. So parallax error which highly occurred in this type of situation. So for the innovation content, as we can see here, for the traditional method, this is a burette and the water is going to flow from the burette into the combustion chamber, into this chamber here. And this plate here is an acrylic plate. So mechanics will have to control the flow of the water by stopping the water flow when the water has filled up the chamber here. So it is fully human control. And then the mechanics will have to get the reading on the burette and put it into a long formulas, so it will be a lot of manual calculation with calculator involved. While on our side, the improvised method is that firstly, it is a water tank with integrated ultrasonic sensor, so the sensor is going to replace the burette reading here. The sensor is going to sense how much water is left in the tank when the operation is completed. The second one is the water solenoid valve, and the third component is the water sensor. Basically, when the water sensor has sensed the water has filled up this chamber, it's going to send a signal to the water solenoid valve, which is fully electronics control, and it's going to stop the water from flowing down. Then only the ultrasonic sensor is going to get the reading from the tank inside. Then these data will be passed into the systems, and the microcontroller is going to process this data and display the compression ratio on the screen here. And this command pad, this command pad is for the mechanics to insert the bore and the stroke value of the engine. As earlier on, there should be a long list of formulas with 8 or 9 different data needed. So they don't have to write everything down here. They just have to type it in and the system is going to calculate it for them. So this is a fully electronics controlled water flow system, automatic calculation, and this prototype also suitable for every type of piston. Either it is a flat piston, dish piston, or a dome piston. So for the mechanism, firstly, we clamp the gauge on the cylinder head, and second, we seal the acrylic CC plate, which is the square plate just now, on the combustion chamber outer surface. Third one, we insert the acquired dimensions via the keypad, and we start the process. And fifth, the value is going to appear on the screen. So for the customer benefit is that firstly, it reduces the time consumption of a job, because sometimes when mechanics realize they get a wrong reading or they overflow the combustion chamber, so the reading inside the bearings is totally irrelevant. So they have to pour the water out and repeat the process until they get the proper or the perfect accurate stoppage for the water to flow. So it will cost them a lot of time. And the second is we can improvise manpower utilization, as both novice and experienced mechanics can do the job. because the stereotypes or the common among the workshops is that only the experienced mechanics get to do this type of work because their experience make them qualified to know when to really stop the water flow. And the third one is it can measure engine displacement and compression ratio at once. So both of these values is going to appear on the screen. So for the comparison of the time taken, for the traditional method, it will take them around 30 minutes to 1 hour per engine, while the improvised method or our prototype will take them around 5 minutes to 10 minutes for a normal 4-cylinder engine. And for the comparison of wage per hour, we will put the standard wage for novice mechanics, and based on our comparison, we get a reduction as much as 83%. So for the market entry, for the structural exporting, we plan to sell this prototype out to the DRB HICOM subsidiaries, to automobile workshops, which any workshop that do overhaul jobs. And third one is the performance or motorsports team. And on the right hand side is our distribution layout, which will be through our distributor, retailer, and to the end user, which the automobile workshops, and our operative partner, and this prototype which will be available for the company subsidiaries under our operative partner as well. So for the scalability potential, we plan to have our product run into manufacturing, and we plan to reduce the manufacturing time by 20% in the first quarter of our year 2 operation. And we plan to offer compression ratio inspection services on the third quarter of second year. While for the business progress, we would plan to have collaboration with motorsports team and the penetration of this product into automotive college or university for education purposes. So for the resource requirement, in total, there will be 13 components will be needed to build up one of these prototype. And all of this price is a normal price, which is not a wholesale price. Hence, if we were taken all these components in a huge amount, we can get them in a wholesale price, and the total amount will be much, much more lesser compared to the one that appears right now. And this is one of the achievement that we managed to get by using this, by introducing this prototype in an innovation competition last few months. So right now, I'll be doing a test on the coding which will be used on the prototype. Basically, the mechanics or the owner will have two options. The first option, or option A, is the calculation of the compression ratio with the block attached on the cylinder head, while option B is the calculation of the compression ratio without the block attached on it. And in this case, I'll be doing an example for option B. So all the measurements that must be inserted, or the data that must be inserted into the system, must only in millimeter, while the chamber volume must be in cubic centimeter, which should be obtained from the sensor on this prototype. And in this case, I'll be using the bore and a stroke of 85 mm. And hence we will get our displacement, which is 482.4 cubic centimeter. For the chamber volume, which will be given by the sensor on the prototype, the data will be directly transferred into the program or into the coding itself, and the system will process the data. And in this case, I'll be putting on a sum or a normal amount. And at the end, we'll get the compression ratio of the engine, which is 9.0 to 1. So I guess that's all from me. I wish a good day ahead to the jurors and to the judges. Thank you for watching this video.